Hello everyone, welcome to my second video in which I am going to be solving June 2004 Cambridge A-Levels examination, and the paper is 32, which is paper 3. So the question is particularly related to the integral calculus. I will be solving a question in which integration is concerned. So I hope that you have prior knowledge to integration, because obviously over here I am not giving the basics, and I hope so that you have a little bit of knowledge how to integrate or differentiate. So let's tune into today's video. So over here the diagram shows the curve y is equal to ln x over x square has its maximum point at m. So m is the maximum point. The curve cuts the x-axis at a. Write down the x coordinate of a. Over here we have been given e, we have to find out a. Now there's one thing that we know already from the beginning. At y-axis, at x-axis, what is the value of y? At x-axis y is always equal to 0. So yeah, that's it. So now we have to find the x coordinate of a, and we know at x-axis y is equal to 0. So what are we going to do is we are going to substitute, like we know it's 0, substitute y is equal to 0. Sorry, at x-axis y is equal to 0. X-axis y is equal to 0, hence substitute y in equation. Hence substitute y is equal to 0, y is equal to 0 in equation. So it's going to be 0 is equal to ln x over x square. If I take this x square over here and multiply it by 0, so anything multiplied by 0 is 0. So what are we going to get? We are going to get ln x is equal to 0. Now there's something that we know since the beginning from the indices, that when for example when the bases are same, then we can equate the powers as well. So over here we already know that ln x is equal to 0, which is given. So that means if I write it over here like this, e ln x is equal to e 0. And over here we also know that e ln a, this is from the logarithmic chapter. You should know this property, that e ln a is equal to a. So over here what is a? A is x. So this is using the property, this is going to be x, and we know that anything power by 0 is equal to 1. So what is the x coordinate of a over here? It's 1. We just proved that, and we are done with the first part. We got x is equal to 1. Now we're going to move to the second part, where we have to find the exact coordinate of m. Okay, so we know that this is equal to 1. Now we're going to find the exact coordinate of m. So for that we know that as m is the maximum point, so to find the maximum point we know that at maximum point dy over dx, at maximum point dy over dx is equal to 0. Like we usually say that the first derivative is the slope. So if and the slope for any point at a curve is the tangent to that point. So if I draw a tangent over here like this, so what is the tangent of a horizontal line? It is 0. So that's why at the maximum point dy over dx is equal to 0. So we have to derivate this now. So we can derivate this by product rule or quotient rule as well, but I'm going to be using the quotient rule over here. So let's use the quotient rule. Now we know dy over dx is equal to x square. Now I'm going to take the derivative of ln x. The derivative of ln x is 1 over x. Now I'm going to subtract it. Now I'm going to write ln x, and now I'm going to take the derivative of x square. What is the derivative of x square? It's 2x. The whole thing will be divided by x square bracket square. So if I see, this and this gets cancelled, so I get x minus 2x ln x, and I know that if I do this, the powers are going to get multiplied and I'm going to get x power 4. If I see from above that x is coming out as common, so I'm going to get x 1 minus 2 ln x over x power 4. So this x and this x is going to get cancelled, and what I'm going to be left with? I'm going to be left with 1 minus 2 ln x over x cube. So just like I've already told, that at the maximum point dy over dx is equal to 0. So what I'm going to do is, let me add another page. Sorry for that, I should have done it already. Sorry. So over here we are again, I've got it. So let me take it from above. What did we get? So here it is. We got 1 minus 2 ln x over x cube. So we know, let me write it over here, and we know dy over dx is equal to 0 at the maximum point. So it's going to be 0 is equal to 1 minus 2 ln x over x cube. So I'm going to take x cube over here. So we're going to be left with 1 minus 2 ln x is equal to 0. So what we're going to get is, I'm going to take 2 ln x over here. So we're going to get 2 ln x is equal to 1. So ln x is equal to 1 over 2. Now what are we going to do? We are going to take this in the e ln x, because I've already told you, we know that these two are equal, and we also know that if the bases are same, their power are equal. So using that, we can easily write that e 1 over 2. So what are we going to do? E ln x, x, like this again, e ln a is equal to a, e ln x is equal to x is equal to e 1 over 2, or I can also write as that under root e. So now you don't remember that in the question it's given that the exact coordinate of m. So whenever in the question it's written exact, so you have to leave your answer in this form. You don't need to write the decimal. Remember that your marks are going to be deducted if you don't follow this. Whenever there's written exact coordinate of m, you need to be really careful and not write your answer in decimals. I'm going to cover the third part in my next video. Be sure to watch that. Thank you so much. See you in my next video. Like, share and subscribe please.